Today, what we're going to be talking about is horizontal translations. But what does that mean? That just means that it's going to move to the right and to the left. So if you have some type of graph and then you do something to it and it moves to the right or the left, that's just a horizontal translation. But we like to call it a phase shift. Watch this. If I drew a graph looking thing and then I graphed a paperclip, I graphed the paperclip somehow, and then I moved the paperclip to the right, I have shifted its phase, or another way of saying it, horizontally translated it. And if I go to the left, I have now phase shifted to the left, or horizontally translated it to the left. And that's exactly what we're doing today. Now, the way that it works inside of an equation is as follows. If you look, we already know from our general form of a sine, cosine, just trig functions in general, of the a and b. We already know what they are and how to use them. What we haven't seen is this minus h. This minus h here tells us exactly how much we go to the right or to the left. How do we know what this h value is? The h is subtracting directly with the theta. The b and the h are both inside of this cosine function. However, the h is doing its thing more directly to the theta than the b is. Notice it's on the outside of these parentheses. Now, the only thing to remember is that whatever the h is doing, it's the opposite of what we would think it would normally be. For instance, if we add something, we would think that it would go to the right. Right, for you guys. And if it was subtracting, we'd think that it would go to the left, but it is the opposite. With phase shifts, it is the opposite of whatever we think. So for instance, if we look at the examples down below, it says y equals cosine of theta minus 90 degrees. So that means that we're going to go to the right 90 degrees, or 90 units in this case. And then the one right after that is y equals tangent of theta plus 30 degrees, which means that we go to the left 30 degrees, or 30 units to the left. Let's try out an example of this. And the nice part about this is that you're not being asked to graph these or anything like that. When you are asked to graph these, it gets a little bit more complicated. But for right now, all we need to do is identify what the graph is doing. Now, first of all, the amplitude. We already know what amplitude equals. That's going to be the absolute value of our a value, and our a value right now is 1, so we'll say our amplitude is 1. Now, our period is based on our b value, so that means our period is going to be 360 divided by the absolute value of our b. Now, if you notice, I used 360 this time instead of 2 pi. I did that because inside of our trig function, we are using degrees, not radians. And also on our graph, it is being measured in degrees, not radians. Therefore, I'm going to use degrees in this case and not radians. If we look at our b value, it is also 1 because we can't see it. So that just means that our period is going to equal 360. What does our phase shift do now? Well, if we look inside of the equation, it says theta minus 90, which is the opposite of what it's doing. So that means it's going to go to the right 90 degrees. The phase shift is going to be 90 degrees to the right. And that is it. That is all that it wants us to figure out at the moment. So let's give this a try on the guided practice. Now, this is the point that I want you to pause the video and try to figure this out by yourself. And I really feel like you can. We want 3 things. We want the amplitude, the period, and the phase shift. You got this. Thank you so much for pausing the video, and I know that you tried your hardest. So the first thing is that we are working with the equation y equals 2 cosine of theta plus 45. Let's see what we can get out of this. First thing is first, we want to find the amplitude. So our amplitude equals the absolute value of a, which that means our amplitude equals 2. Our period is going to equal 360 divided by the absolute value of b. Now again, I reiterate, I'm using degrees because in my equation it says 45 degrees. Therefore, I will use degrees, even though that radians are like so much better. So the period will equal 360 because my b value equals 1. So it's just going to be 360 divided by 1. And I'm too lazy to draw out multiple steps here. So I will just say 360 degrees. Very nice. That is my period. Now my phase shift, or PS, I have to look at what is inside and adding or subtracting directly to the theta. In this case, it looks like that it's going to be theta plus 45 degrees. So with this particular right and left translation, I have to think of the opposite. So adding 45 degrees on the inside means I'm going to be going to the left 45 degrees, or 45 units in this case when we're graphing it. So we will say left 45 degrees. Very good. All right, so I got all the way through this entire lesson and I failed to realize that the question asks us to graph it and I never graphed it. So let's do that now. First things first, I'm going to draw my midline. Now, right now, we haven't really talked about moving our midline, so it's always, at the moment, until next lesson, is going to be at 0. Now, what we're going to do is that we want to draw our upper and lower bounds of this graph using our amplitude of 2. Our amplitude of 2 means that we're going to be going to above and to below that midline. Now, usually when we're graphing these things, we're going to be starting at 0. But our phase shift means that instead of starting at 0, we're actually going to be starting at whatever the phase shift took us to. So since it went to the left 45 degrees, that's the value that we're going to be starting at. We're going to call that negative 45 degrees. Now, since our period is 360 degrees, that means it's going to take 360 units in this case for it to complete a full cycle. So we're going to mark 360 degrees or units past negative 45 to find out where our period ends. In this case, it's going to end at 315 degrees. We want to do the same thing that we always have. We want to take this section and we're going to divide it up into 4. This is now divided up into 4 equal parts. Now, the tricky part is finding out where does our first line after negative 45 actually reach. Well, if our period is 360 degrees, each of those sections is going to be 360 divided by 4. So let's do that. What is 360 divided by 4? 360 divided by 4 is going to equal 90. So each one of those sections is 90 degrees. So in this case, negative 45 plus 90 will take us to positive 45 onto the other side. And we're going to add 90 every time to get the next line. I understand this is not completely to scale. It should be the exact same distance on either side, but I'm not perfect. So adding 90 again, we get 135, then we get 225, and we have all of our marks and all the information necessary to be able to graph our trig function. Now, as we know with our cosine functions, we're going to start at the maximum line, and then we're going to go down to the midline, all the way down to the bottom, then back up to the midline, and then again to our maximum line there. Now what we're going to do is that we're going to connect everything with curved lines, and this should make a nice little cosine graph, a nice little wave function here.